Let's go. Good morning, good afternoon, good evening, good dawn, good wherever you find yourself. This is IoT Tuesday, and I'm yours truly, Samuel Adranyi, bringing you another episode of the Mystifying AIoT to the barest minimum. If this is your first time, we do this every Tuesday, 8 p.m. GMT. We try to demystify IoT, make it easy to understand. We do unboxing, we share tips and tricks, just to make your life easy on the journey to IoT. I'm yesterday someone joining you again, and in this week's episode, thank you for joining. In this week's episode, we'll be taking off of last week. So last week we looked at the SIT Studio ESP32 board, and we tried to connect an external sensor to it. It was giving some problems. So after consulting the gods, of Discord and all the other community members, we were able to fix it, and it actually is what I want to talk about in today's episode. So we're pushing an episode forward just to make sure that you grasp the concept of dealing with this new board. So I'm going to share with you the fix, how we got it to work, the libraries I used, and then we'll see how to do it. And we'll just talk about it. And if you have any questions, drop them. We'll answer it. So if this seems like something you want to stick and stay with me to do, we will be right back and we'll get into it. Awesome, we're doing everything IoT, and as you know it, okay, before I get started with each episode, I like to throw a few things out there. I think over the last weekend, no, it wasn't the last week, it was like last week, was it Friday? I think so. Last week, is that Thursday or Friday? There was a workshop by the local ARM group. Interesting conversation, and it's in the next couple of weeks, as things unfold, I'll try as much as possible to share some of the information that came out of that meeting. So you're not alone, all right? If you're into IoT, a couple of things coming up. I'm still making the call to those who want to join the Accra AIoT and DIY user group. We're scheduled to kickstart it in September. So I'll drop the forms as part of the show, and then if you're interested, go fill the form out. Let's meet. Let's know what you like to do, and let's join the family of makers, make things, break things, and learn stuff. The next thing that I'm excited about is officially these are coming out. Yay! Yep. Yeah, the official IoT Tuesday shirts are coming out. So I'll be giving some away, and then also we'll see if you're interested in it. Just let me know. Okay, so let's get into it. So last week, we set up the SIT Studio ESP32C3 board. Small form factor, powerful, processor and stuff. and we're having fun. We're able to set it up, install libraries, and do all that. But we're still not able to read the sensor values. Fast forward, let me take you to the bench. Now, fast forward. So this is a setup we have. So here we have our tiny C Studio ESP32C3 board. We have an extension board that allows you to mount most of the XIAO boards. This is also a XIAO board. So mount the XIAO board on it and gives you groove extensions. We have a DHT temperature humidity sensor here. So now we saw the differences in last week's episode. This one doesn't have sensors, right? So you pretty much would have to augment it with your own external sensors. And wanted to read the temperature and humidity in the room and then have this reported somewhere somehow. Now, when we loaded the initial sketch, all right, which was supposed to be out of the box, if you're using the Groove DHT sensor, it doesn't work for now. I mean, at least from our test, it wasn't working. So we had to figure a way around it, and that's what I want to share with you today. So the workaround, let's open Arduino and also open the seed. And actually, you know what, let's see. Let's see. Oh, I think I already have it, so I'll share that. I'll share that with you immediately. All right. So let's go open an Arduino IDE, and let's go to the Seed Studio. Okay. So let's switch to this view. And welcome to the show, wherever you're watching us. Feel free to send us a hi, and let's acknowledge you on the show. All right. So I'm going to zoom into this code. All right. But first of all, let me just open the tools serial monitor. I think it's just on the same COM port. There you go. So as you can see, let me clear the output and reset it. So as you can see now, we're getting the temperature, the humidity, the heat index as well. So at the moment in the room, humidity is about 81%, temperature is about 24 degrees Celsius. There's plus or minus there. So this is coming from the setup you saw on the workbench. All right. The setup coming from, if you want to see me mess things up, let's go to the 4 views. I'm just going to try to blow some air on it, and you can see here. Hey, welcome to the show. Welcome. Hey, welcome. We're demystifying IoT here. If you have any questions, you can drop it. So I'm just going to blow some air onto the sensor right here. All right. So all I did was just blow some air on it. And then if you keep watching here, you see it's jumped from 24 to 28 degrees Celsius, 82, and coming down 24. All right. So for this to work, couple of things. We had to do a couple of things. All right. And that's what I want to share with you today as to what we had to do. Now, if you, this is specific to the Seed Studio XIAO ESP32C3 board. All right. The small kit that you're seeing here. This one. This tiny one. What's the other one? Yeah, I have a bunch of them here. There's a bunch of them, but it's just very tiny. It's this one, this very tiny one. Okay. Now, if you download the Seed Studio libraries for the Groove libraries for the temperature and humidity sensor, and you use the default or the example sketch, it doesn't work. Right? It doesn't work. So I'm going to walk you through how we set it up for it to work. And then if you have any questions, you can take it, and then we'll discuss how to now send this data to Quibitro or to Azure or to any of your cloud providers or to MQTT, to a local broker, how you want to do that. Okay. Because it's ESP32, it speaks, it can do MQTT. All right. So let's do this. Let me take this off for now. And then gonna open, let's open our, where's the XIAO. Yeah, we have the XIAO boards here. And you have any questions, please feel free to drop them in the chat, and I will try as much as possible to answer it. Okay. So if you missed last week's episode, just please subscribe to the channel. Last week's episode is there. All right. Okay. All right. So this one, okay, as we talked about, the ESP32 has Wi-Fi, has Bluetooth on it, but then doesn't have any sensors. All right, it's just bare. So you can communicate. You can use it to build, small form factor wearable devices, solutions that require small form factors. So you want to do something inexpensive, you can use it to do it. Okay. I want to, and I think last week I shared a lot of information on, how to leverage it. All right. So let's see this. Let's see. Okay, cool. And there's quite, a lot of stuff here. Okay, now let's go through this code. Okay, let's go through this code first. Now, this here is your mostly your very common Arduino, how do you call it, sketch. All right, you include the library, you define the pin on which you want. So the highlight or the pointers on what to look out for if you're using the XIAO ESP32 module, these are the things to look out for. Okay, so Ada fruit DHT, yeah. All right. So if you look at the Safe Studio example, and I'm going to walk you through the whole process, it will you might be tempted to go through that one and use the temperature and humidity sensor library, DHT11 libraries that Seed provides. It works very well for the XIAO BLE and BLE Sense. All right, it works fine. You can use that. Just use the example sketch, like here. If you go to File, Example, and then if you have the let's say we are using ESP32, but let's do this. Yeah, let's see. Where is that? Yeah, I have a few of them. So we're not using wire. So let's see. Either fruit, groove. Okay, so if we decide to do, you see, yeah, so this, okay, if you use or download and use the groove temperature and humidity sensor library, hey, welcome. Yeah, no, you're not 21 minutes late. We started 8:10, so you're just like 10 minutes late. Okay, so yeah, so the groove, if you use the groove temperature and humidity sensor, okay, if you download this library and you use a DHT tester example, this doesn't work with a XIAO. At least from my test, it doesn't work with a XIAO. All right, so you know what, maybe we should just go ahead and open that example, and I can compare the difference for you to see. Okay, cool. So a couple of things here. Let me open this one up. I'll try to do it side by side so that you understand where I'm coming from. Okay, let's do this. Let me squeeze this one to the left and put this, sorry, to the right and to the left. Okay, so what you're seeing on the left is the code that works on the XIAO, on the ESP32, the XIAO ESP32. And the code on the right is the default DHT tester example that comes if you install the Seed Studio temperature humidity sensor library. All right. So yeah, you would think, yeah, include dht.h, that's it. You specify the type of temperature sensor you're using. We're using DHT11, so you can uncomment it. That's the same thing. Now here, see the difference, right? Here it's saying DHT, the pin is pin 2. Yes, the pin is generally pin 2 on I think on the XIAO BLE Sense, and most standard Arduino base boards is pin 2. All right. However, our test and debugging realized, or we found, that just doing this doesn't work. You need to be specific and say D2. Again, if we look at the schematics, okay, let me come here. Okay, so let me bring this here briefly. All right. Now, if you look at the schematics, if you look at the pinout diagram for it, okay, this is the ESP32C3. So D2, A2, realize that it is the same pin. All right. Because it's the same pin, you need to be specific and say, hey, I'm actually using D2, and then it does its own things for you. All right. So that is the first gotcha. So that was the first gotcha. Well, not the first. The first one was the library. I'll come to the library. But in terms of the code itself, this was the first gotcha. So if you use 2, it doesn't work. So you need to use D2, correct? And then here, we're pretty much doing the same thing here. We are just creating a DHT type, and we are creating an instance telling it is going to be on pin D2 and is of type DHT11. That's what we're doing on this line. We're telling it we want to create an instance of a DHT sensor, and this is where you can find it. Then here, nothing really fancy. Yeah, nothing really fancy here. It's the same thing. Here, if you're using the example code, has some logic to determine whether you're using serial, USB, and stuff like that, but that's fine. The baud rate, still the same. So pretty much opening a serial, writing a message we're testing, and beginning the opening the DHT instance to reading. Now, the other thing here is also using the wire. There's some funny thing with the wire, which is apparently the way it communicates, by the lines. So realize that for the XIAO 32 ESP32, we don't use the wire. All right. So there you go, DHT begin, and then you can do a loop. Now the difference is that if you're using the Groove DHT temperature and humidity sensor, all right, you have a method here called read temp and humidity, right? And then you can pretty much deduce it. But if you're using the remodified code, the Adafruit temperature and humidity sensor library, you do read humidity, right? And then you do read temperature. I think I can close this now and make this big. So read temperature, by default, if you don't pass in any variable, right? If you don't pass in the Boolean variable of true, it's going to return it as Celsius. But if you want it to return it in Fahrenheit, for those in the US, you can pass in true to the same method, read temperature with true, and it's going to return you in Fahrenheit. Okay. So pretty much, we're doing a check to see if we don't have a standard. This is all we kept getting. The humidity, temperature, and heat index. Sorry, heat index, temperature, humidity is not empty, right? If it's empty, we tell you that, hey, we don't have anything here, but else we go ahead and get the, temperature, humidity, calculate the heat index, and then just output it. All right. So very basic. That's what we're doing. Now to the tricky part. This sensor, this DHT sensor, takes a little about 2 seconds. It takes 2 seconds to 250 milliseconds to warm up, okay, to come up to yourself and start reading. So it is good to provide some ample delay from beginning of your loop so that it will warm the sensor up before you start reading values. Else you might be getting nothing. All right. So that's another thing to look at. So pretty much this is not the code. However, now you might face this challenge when you're using Arduino IDE, because you might have conflicting libraries. So for instance, because Most of the libraries derive from other libraries. Let's say if you install the Groove DHT temperature and humidity sensor library, and you installed also the Adafruit DHT library, and you are using, and now here's the thing, a couple of things, rookie mistakes that we get a lot. Now, when you do, one thing you need to understand is that the Arduino IDE, the folder structure and how it actually references libraries, okay, or in some language balances, namespaces you use, it starts from its local or from the root and then works its way up. So if you are inferring a global or general library, it will start to look for it in its root. If it doesn't find it, it will go to the global scope. All right. Now, so it's good practice to include the headers there, right? Within, just with the headers and the header files within your root folder, and it's going to pick from there. All right. If you go ahead and you do, in most cases also, I realized that if you put in the quote, it means, hey, I'm trying to start from the root. I'm trying to find it from the root. If you do the square bracket, the angle bracket, then obviously you're saying, hey, go into my library manager and look for this, library for me. Okay. Now, another thing we did was, let me show you this, just so you know that we're referring to specific files or libraries within the folder structure. So let me bring this here first. Okay. And this is, no. So I think it's rather dev. And please feel free to ask any questions. Okay. No question is dumb. Hey, Evans, Amegashi. Welcome, Evans. Welcome to the show. Yeah, resetting the room. Last week we got started with the Seed Studio XIAO ESP32C3. Let's go to the bench to show it to you guys. Is this tiny? Yeah, it's a very tiny board here. It's part of the the Seed Studio XIAO families. Is quite very small. So this board, we started a series of unboxing and testing all of them, and we set up one. This one has ESP32 running on it. So last week we started unboxing it, we connected it to the expansion, and we put some code on it, but there was some problems. So I went to fix it, and today we're sharing how we fixed it, and then we'll see how we can now send data from this tiny thing, reading from the DHT temperature sensor to Azure, Kubutro, and other cloud systems, and then into your local MQTT brokers. All right. So back to the screen. So this is what I was talking about. Now, this code you're seeing, this is it. And in here, I put the header file, okay, for the DHT library I want to use. So when this code is running, based on this line up here, it's going to infer the DHT library from closest to the sketch. If it doesn't find it, then it will go up again, up the level. All right. So that's what you need to be mindful of. Now, the next thing I want to share, let's bring this here, is actually this library. So this is what we used. I didn't use the DHT temperature humidity sensor. I used the Adafruit sensor. All right. So this has a bunch of stuff. So Adafruit has the universal sensor and has one for DHT sensor. So the GitHub repo, as you can see, DHT sensor library, this is the one that I used. So I downloaded it and then included it in my sketch, and then pretty much it worked. And like I said, for some reason, the Groove DHT temperature sensor library, if you install that and try to use it on the XIAO ESP32, it won't work, at least for now. All right. So that is how it was solved. So for now, you can see that if we open the serial monitor, yep, we are still reading temperature and humidity data. Okay, let me reset. So you can see ESP32C3 API 1. Let's clear the room, and then we are reading the data. All right. Awesome. So that was a problem. Okay, that was a challenge we're facing. That made it difficult for us to read. We're getting null values and all that. With nothing, it was just saying was erroring. So to go back to the pointers, right? The pointers that we used. One, let's go back here. Use the Adafruit DHT library. That's one. And then two, make sure you clearly specify you're using D2, not just 2, D2. The example sketch would just say 2, but make sure you're saying D2, which is because, as you can see from here, A2, D2, GPIO 4 are all on the same, all right, on the same pin, this particular pin here. So you have to be specific, all right? That's the next one. And pretty much that's it. I think we are not using the wire, right? So that, yep, that is how we overcame the issue of the DHT sensor. And then now we're able to read the temperature data. So the next thing, like, let's go back to now look at some of the functionality. We said because it has Wi-Fi and Bluetooth, we can leverage Wi-Fi and Bluetooth, like this data we're collecting, now send it out to the cloud for some kind of processing, all right? Whether you want to do some stream analytics with it, whether you want to just look at the difference and then react to it or do something in any cloud that you want to, you can do that. That's the next thing we would explore. So we're supposed to have done that in today's episode, but I was very specific. I wanted to share with you the issues and the challenges and how we go about it. Now, let's explore the libraries or the documentation for it so that we can leverage that for next week. Now, Azure IoT has also released a CSDK specifically for Arduino, working with the Azure IoT stack of tools. Okay, especially for if you're doing IoT Central or IoT Hub, you can use the Azure Arduino C library. You can use that. Okay. Now, right now we're just going to look at generic how to use. Let's look at the Wi-Fi options, look at the Bluetooth, and let's generically look at the other options we can do with it. Okay. Now, and I think I forgot to mention this. Last week I made mention of it, and today I just forgot to mention from the start. So Google is discontinue or sunsetting all its IoT call managed services. So if you have that was as of 16th of this month. So next month, 16th August, they're going to discontinue it. So if you have workloads in Google, right, Google Core IoT services, you need to move them either to Azure IoT services or Qubitrol Cloud Service, depending on whichever mix, but we use this too, so you can migrate it. Last week, I shared a document by Qubitrol on how to do it, and I'll be sharing how to migrate those also into Azure IoT Hubs and Azure IoT Central and other services. So if that is interesting to you, just drop a comment or something in there, and I'll just walk you through that. All right, so let's keep this here, and let's go ahead. So for those of you asking what's a XIAO boards are, XIAO is a family of seed boards. They have you can see they have a lot of this. We've seen the XIAO expansion board, which is what we are using. It's a tiny board that has a groove thing on it. We've seen the XIAO we've seen the XIAO RP 5284, which is a sense, and then RP 2040. All right, we've seen all these things. Now, because of focusing on this, we've already done this. Now, Wi-Fi is a big part of your XIAO. All right. Wi-Fi is a big part of the ESP32 XIAO stuff. So if you go back to the bench, you can actually even see that there is the antenna here. All right. So you see your Wi-Fi antenna. This allows it to good reception for Wi-Fi wherever you put it. Okay. Now there's also Bluetooth. So if you want to do stuff that doesn't use Wi-Fi directly, you can leverage it to do Bluetooth, which means you probably will need some interface or some application for it to transmit the data for you to send. So I think last week I gave an example. I was giving an example of imagine you have a companion app, okay, like which speaks Bluetooth to the XIAO ESP32, right, or any of the BLE versions, and they are reading data or performing something, and then you can now interact with a mobile app that speaks Bluetooth with it, and using the data on the phone to send it to the cloud or wherever you want to send it. And the good thing is that the BLE Sense, you can actually run tiny ML AI modules on the BLE Sense. Yes, and we'll do that as part of the series. So for the rest of our series would be XIAO, setting up Bluetooth. We'll try to explore all the XIAO options, everything on the XIAO, before we leverage it into a final project. All right. So let's go ahead and take a look at this. And yeah, if you have any questions, please feel free to drop it. Okay. So we have, as you can see, we have this here, and in most cases, okay, there are very simple, very simple and easy ways where you set up the Wi-Fi, okay, with it, and we can use some of this example codes. Most of the common thing is being able to scan for available Wi-Fi devices, so Wi-Fi networks, and then it can also search for it, or you can directly just put in your Wi-Fi information, and then you create a Wi-Fi connection. Now, once you create your Wi-Fi connection, you're going to now use your Wi-Fi connection to either send the data and stuff like that. Okay, so let's see if we can do that. There is this, guys. Hold on. I think I should share this before we move on, and because I keep getting a lot of this. Where is that? Sorry guys, I'm trying to find. I wrote it somewhere. Where is that? I'm not sure. Let's see. I'm trying to remember where I put that. So let's see. ESP32 Wi-Fi configure. I've forgotten the yeah, I think it's Wi-Fi manager. Yeah, I think this is it. Or is it? Yeah, it's Wi-Fi manager. Yeah, it's Wi-Fi manager. Let's look at this. I think this is it. Yeah, so yes. Now, this is a very good resource if you are doing a lot of stuff specifically. Let me actually put this here in the chat for those who, if you're doing things specifically to ESP32, this random net tutorial is a very good resource. I use it myself to look up things. Now, there is this Wi-Fi manager async web library, right? That is utilized a lot when you're doing ESP32 stuff. And let me walk you through what it is. Now, you know that most times when you're imagine with this tiny, if I build a solution, okay, with this XIAO ESP32 and I deployed it. Now, I don't always need to be modifying the SSID for the Wi-Fi and the password and all that in code, right? That will make the application not useful, right? Because then it means that anytime I want to deploy somewhere else, I need to go in code and change the Wi-Fi. No. This Wi-Fi manager, all right? This Wi-Fi manager allows you, if you deploy it add it to your code base in your ESP32 application, what it does is it allows you to use your phone, right? And your ESP32 compatible device to actually set up the Wi-Fi you want. So it starts off as a web client, right? So it runs a mini web client on your ESP32. So the first time you turn it on, it becomes like an access point that you can connect your phone to. It has a very small interface like you're seeing in the mobile app there that allows you to enter the SSID, the password, and maybe IP, and then you submit. Once you do that, it writes that in memory on your ESP32, and now we'll be using that Wi-Fi. So now I can now deploy applications using any ESP32 device and not worry about having to go into Arduino ID or Sketch to go and change the SSID, right? So the user can directly just pick, all right? The user can just pick that, pair it with his or her phone, and then they can set up the ESP32 to use any Wi-Fi, all right? So I think, yeah, where did I put that? Yeah. So that was something that, where is that? So let's see. There you go. Yeah. So go check that out. For those of you building stuff with ESP32, check this library out. It allows you to, make your ESP32s sweet, right? You don't have to be constantly updating and all that. Updates in your what Arduino Sketch. All right. So yeah, that is it. So let's see. Let me put this here. Give me a sec. There we go. All right, awesome. So now the next thing we're going to talk about, like I mentioned, is like I mentioned, the ESP32 XIAO the XIAO ESP32 has Wi-Fi, has Bluetooth. Okay, so we need to look at, first of all, how to set up the Wi-Fi on it, and then maybe leverage Bluetooth if we want to. Okay, but that is going to be in scope for next week's episode. Today we're just fixing the issue with reading sensor data from it. I don't know if we can do another sensor data. Let's see. Let's go to the bench and see if we can add. We've added the, thank you Evans, we've added the temperature humidity, which is this one. Okay, we've added the temperature humidity. Let's see if we can add another one. Let's see. Let's see. Okay. Yeah, so let's see if we can add, since today is just connecting external data sensors to it, groove light sensor. Let's see, well, there's already lighting here, so let me push a few sensors here. Let's see. Okay, so this is an LED. Let's see. Now this is another temperature and humidity sensor. All right, but this is I2C and it's high accuracy. This is an SHT35. Okay, this is an SHT35. This is a high accuracy temperature humidity sensor, but from Groove. All right, so I think you can see that from here. So this uses I2C. All right, so this one here. So I'm thinking maybe we do something along the lines of an environmental sensing thing. I mean, though we are pressed for time, I just want us to show the other sensors we can connect to it. And that's the more reason why I am using the Groove. All right. That's the more reason why I'm using the Groove. I'm using the Groove. Actually, I was going to the bench actually. So that's why I'm using the Groove, the expansion board here. So I can easily just connect this and not do a lot of soldering. Okay, makes my life very, very easy, right? Okay, so we have like 10 minutes. I don't think we can do a lot in the 10 minutes, but just to introduce the concept and things to you. So in next week's episode, we will be connecting we'll be collecting all this data. All right, all this data we're collecting from the sensors and the ESP32. We'll be leveraging the Wi-Fi, okay, the Wi-Fi capabilities of this, and then sending it, okay, to any of our cloud providers. All right. So before we leave, let's go ahead and let's go to the workbench. Let's see how to set up the Wi-Fi quite easily. Have it, do a few. I think we can do that before we go. At least we've seen connecting the sensors will not be a problem. We just have to connect it, use the right libraries, as we've seen the DHT. I'm going to make the GitHub repo available for IoT Tuesday and then the various episodes, and you see all the codes and stuff there, so you don't have to rewrite everything again. So let's go to the bench. Let's bring this and let's get the USB usage. My in-ear monitor keeps falling out. Okay, so if you have any questions, please put it in there so I can answer it. If you have any questions on it, I can answer that. And I think some good news also coming through. I'm holding off on that. I had a conversation with Sigfox representatives in the country. So pretty soon there's going to be a lot of deployment for Sigfox network. So that means that you can do a lot of long range connectivity with IoT devices, not necessarily leveraging on LTE and GSM. So some news coming up. So more details on that. When that happens, I'll actually talk more about it, and who knows, we'll just see where some of the maps are. So let's go. So like I mentioned, the antenna we saw on it is both for Bluetooth and for the Wi-Fi. Okay, now so you can have it in station mode, okay, or access point mode. These are the two modes you can have it in. Now station modes means you can scan to see all the Wi-Fi around. Okay, so let's see. In this case, I would change. So in this case, I'm going to test this again and see. And I think I've already installed the. I think I've installed the Wi-Fi module already. Okay. So if you haven't installed it, I'm just going to do this and test it. So here I'm going to try to compile it to see if I don't get any errors with the library. Okay. Let's see. Let's compile. If it compiles good, that means that it's able to resolve the libraries and don't have any problems. All right. You can use the base Arduino library, so you can use Adafruit library. That's fine, right? They all work fine. If you don't know how to do that, you go here to your sketch, include library, and then you go to the library manager. The library manager will open for you to either search for libraries and download. But if you've installed it, as you can see, I have a bridge. I have a lot of libraries installed here. And there you go. You see, I have Wi-Fi. I have a lot of them here. All right. So I hope I don't get a conflict. Drop your questions. If you want any clarifications, ask them and we will be okay. So whilst okay, I think it will compile very well without any issues. I believe so. Yeah. There you go. I think it worked. So which means it resolved our Wi-Fi library correctly. That's all we need. Awesome. So now in our setup, okay, let me actually increase the baud rate 5200, And we can begin all these things as well, but once we begin, I want to do, so let's go ahead. Let's say set up Wi-Fi here. Okay. So what we're going to do is we need to set the mode. Okay. We need to set the mode, and because we're starting with staging, I can do Wi-Fi underscore staging. So we're setting it into staging mode, and then if it has any Wi-Fi, if it's connected to any Wi-Fi, we are actually disconnecting it. Okay. Let's give it a short delay to process start disconnect and wait. And DHT testing, and then we can just print something here whilst it's done, and then we say Wi-Fi setup done. Okay, so let's save this. So you realize that all I'm doing is gradually just building and infusing it into what we have, so that as we're reading the data, I'm not messing up with the data. But if you want me to separate it, I can do that as well. We're just building upon what we have. So we only included the Wi-Fi library, all right? And then we're setting, so let's, you know what? Let's comment, right? So set up DHT sensor. Set up Wi-Fi, there you go. So we do this. So now if we check this, and it's always good to compile and check to make sure that your code is okay, your firmware is okay before you push it. Okay, so there you go. And I mean, so what I can do is that I could have created, so this is what I can do. I could have created a separate function called setup DHT sensor and a separate function called setup Wi-Fi, and then call them in the setup method. All right, but we're just going through this in the very basic. So this also worked well. So how about we, you know what? Let's just let it do print. Well, let's let it list. Let's do this here. Okay, so let's go ahead, and I think we can bring this. So let's say, sorry, starting network scan. Okay. And then, so the network is going to return the number of network it finds. Okay. So let's call this N will be equal to the Wi-Fi dot, let's see, is scan, sorry, network. Sorry, guys. Scan networks. And please, I don't have this in, hey, welcome. Hey, right now I'm stuck at ESP32 SDK series. Oh, okay. Don't worry. You can always catch up. You can always catch up. But let me know if you're facing any specific problem. All right. Me here. If you're facing any specific problem, all right, let me know, and then I would help you go through it. Yeah, that series is also there. We connected it, we moved it to, so just go through it. If you have any questions, either drop a comment. I send you connect and follow request on LinkedIn. Please accept. Sure. I will do that. I'll do that right after the show. Thank you very much. Right, and make sure you subscribe and bring all your friends to subscribe. Let's make things happen. All right, so yeah, I think we have a couple of minutes more to go, so we can do this. Yeah, so we'll talk on that. So yeah, like I say, don't think I don't have this all in my head. Always use the documentations that come with all your all your components or your libraries and stuff like that. Okay, don't try to be Superman. If you're superhumans who can do that, that's them. But I can do that. So I always look through the documentations and we learn together and build stuff. Okay, cool. All right, so this is going to give us all that, and when we are done, we can, I can do some 3 dots to make it look, fancy. And then we can say, we can do this and and say network scan completed. Okay, boop. So save this. So this does a scan and saves it. Now, obviously, till now, no problem. Tomorrow I'll continue with the series if I get stuck somewhere. Awesome. Yeah, that's why we do this. Thank you so much. So where were we? Yes. So just like any, you need to check to make sure that you found something, right? If you didn't find anything, let's not bother ourselves. So let's do a simple if. Okay, so let's say if n, which is the number of networks, is equal to 0, which means that, hey, we didn't find anything, right? We didn't find any networks. Okay. So there you go. If we didn't find anything, I want us to say, let's do this. No networks found. And let's do a sad face. We do a sad face. Okay. But then, all right, if we found it, okay, I want to print the number of networks. Okay. So n, that'll be the total number of networks found. Okay. So you can say this, and then you can put a space here. So you can say found, right? And then I'll do my happy face. All right. And then we can decide to go through, just cycle through it. All right. We can decide to cycle through it. So since we have it now, let's just go ahead and cycle through it. So what we want to do is in here, I'll do a simple for. Okay, this is where your programming comes in. So int, which is I, from the very first one, I, less than n, which is a total number of, okay, and then I plus increment so that we don't have an infinite loop. Okay, so for all the number of networks that we find, okay, we're going to do, let's print so let's go ahead. So let's print first of all, okay, let's print here, there's I plus 1, and then we're going to do a lot of prints since we want it to be on one line before we move to the next one. And then we're just saying 1. Okay, all we are doing is say, hey, 1, what is 1? Okay, so let's go ahead. Actually, let me do this. Let me copy this here. Okay, and then we want to now print the Wi-Fi. Let's look for the SSID of the Wi-Fi at that index. All right, so 1, 1, 2, 1. So let me make sure I'm copying and closing the right things. Okay, so that is it. Wi-Fi.SSID 1. Okay, good. And then the next one will be, let's put some, how do you call it? We'll put a space here and do this. Okay. And then we'll print here again, Wi-Fi.RF SSI at that index. So if it's at index 1, it's just going to go through it and then state that. Okay. And I think I want to print this again just to close the bracket here, and this time I'll tilt it this way. Okay, and I'll probably need to close this. And then the last one would be to print. Let's look for, and this one I'll print it on it. So we'll let it end the line. Okay, so this will be, let's say the Wi-Fi. Let's look for the encryption and CRIPTION. Let's look for the encryption type of that network. Okay, and then let's check. So if it has encryption, we'll see a couple of them. If it doesn't, we'll just be open. Okay, so if the encryption there is Wi-Fi auth. Okay, so we're saying that let's do this here. So open this. So if the Wi-Fi dot encryption type, okay, is equal to Wi-Fi auth AUT open. Okay, if this says it's an open one, what we do is that we just put a blank space there. Else we say, you know what, it's password protected. All right, and then we close this. Then we give it a delay so it doesn't try to do this all over again. All right, like immediately it will do it, but it will give it some time. Okay, yeah, so once we're done with, where's the else here? Yeah, so after the else, let's print some empty spaces. Okay, yeah, and then we wait for a while, and then maybe we can read the temperature. Yeah, I think that's fine. And then actually, you know what, I'll just give it 5 seconds. That's fine. Okay, solid. So let's test this again just to make sure that we've not done any bad code. So what this is going to do, let's quickly walk over the code again. So first of all, it's going to set up the Wi-Fi, set it the mode to the station mode. It will disconnect if it's already connected to any. It will delay for a while. Okay, where is that? And then it will just start scanning, and if it finds, we'll just list them. If it doesn't find, we'll say no networks found. But if it finds it will tell us the network. It will give us a number of the network, let's say 1, the SSID, whether it is password protected or not. So this looks fine. So I'm going to go ahead and I'm going to deploy this onto the board right now. So I've hit deploy. Yeah, and yeah, that brings us like 2 minutes. So let's see how this works now. So after the deployment, we'll open up the serial monitor and you can see all the networks that it's seeing. Now, next week, like I said, we will be now leveraging this ability to connect to the Wi-Fi, and now use that to collect the data we have and send it primarily to any MQTT broker endpoint. Baby steps, and then we can now push it to either Azure IoT Hub, push it to Azure IoT Central, or push it to Quibutro, any of the cloud providers we want to. All right. So as you can see on the screen, it is deploying. It's finished deploying 100%, leaving reset is done. So now if I go to tools and I open the serial monitor, let's make sure that, there you go. Take a look at that. Look at that. So it's found, and this is going to wait, and then it's going to now start printing temperature and humidity sensor, and then this thing is going to go again. It's because we just did. Now take a look at this. So I'm going to, where is it? Remove auto scroll. So it started, if you can see, so Wi-Fi setup is done. So it started the network scanning and it completed it, and it found 7 networks. Okay, so you can see These are the various networks you found. They are all encrypted or password protected. None of them is open. All right, it found all these, and then it went ahead to report the temperature, humidity, and all the index because we mixed all of them in the code. So this brings us to the end of today's session of IoT Tuesday. Today we saw how to connect an external temperature humidity sensor to the Seed Studio XIAO ESP32C3 module, and then we also saw how to set up the basic Wi-Fi station on the XIAO. All right. Next week, we're going to leverage on this internet connectivity, connect with one of them, and then use that to send data to the cloud. Azure IoT Hub, Azure IoT Central, Kubutro, any cloud. We'll see how to do it. But they're going to be in separate series. Now, if this sounds like something that's of interest to you, please support us by subscribing to the channel. We want to hit 1,000 subscribers. So hit the subscribe button, hit the notification bell, send us feedback. Your feedback makes us grow the channel. If there's any other thing, just hit me up. I'll try to support you or I'll try to help you out with it. I still remain Samuel Adranyi. Enjoy the rest of your week. Stay safe. Let's make the world a better place through tech and anything you do. Catch you next week, and I am out.